try anyway. All right. So my name is Ron Macera. I'm a partner at Neos. Work with Kevin. So thanks, Kevin, for inviting us here. How many of you are familiar with data lakes? Nice. And how many of you have actually implemented data lakes? Not too many. Okay. And how many think data lakes are just 2017 and they're moving to blockchain now?
Well, ours is a data pond.
Data pond? Yours is a data pond?
Not that big.
All right, let's see if I can figure this out. This way? This way?
You may have to point it at the laptop. I don't know.
I had the same issue with yours starting up too here. Let me see real quick.
It's just really, it keeps stuff.
All right, here we go.
Ah, not just me.
No, it's not just you, trust me. It does that. Okay.
You know what? I can, it's close enough.
There you go. You need to use this too. Here we go. Now it's working. Don't ask me why. It's the first slide or whatever it does. The top and bottom. There you go.
All right. So I am a founding partner at Neos. We're a business management consulting company and technology consulting. We're based in Hartford, Connecticut. So we deal, our verticals are mostly insurance and financial services. Being based in Connecticut, we're in between Boston and New York. It's a good place, a good spot in the country for that, though most of our clients are all over. We were founded in 2000. I myself have been in IT for over 20 years. I started in databases, working in Oracle, since moved on to big data in the more recent years. I also worked with Java for a long time, which I think helps me kind of in the big data space, especially if you're dealing with Hadoop, since a lot of those services are written in Java, and a lot of the code that you can write for them is Java based. Helps me a little bit, and I do a lot of enterprise architecture. You can see my email up there. So what we'll be talking about today, I'll start off with the benefits of a data lake. Just, I'm sure you're all pretty familiar with the benefits of a lake, but if you aren't, it'll be a nice introduction to data lakes for you. And I'm going to talk a little bit about a two-speed architecture. Is anybody familiar with two-speed architecture? No. All right, cool. So maybe you'll learn a couple things today, hopefully. Then I'll talk about our design or architecture for a lake that helps you achieve what I would call a two-speed architecture in a data lake. And that includes those 5 zones that you see there. And at the end, we will have a two-speed data lake, and hopefully we'll have some time for Q&A. But if you have any questions for me, you can feel free to interrupt while I'm talking, and I'll do my best to answer. So the benefits of a lake. Right? One of the benefits of a lake, you know, a lot of people ask what the difference between a data lake and a data warehouse is. I think the biggest difference, two big differences, the two biggest differences are, one, a data lake, it's very easy to ingest data because you don't have to structure the data to ingest it, right? For a data warehouse, you have to design your model, you have to do your transform, you have to figure out where all this data is actually going to go in your model. And so before you can actually ingest any data into your warehouse, there's a lot of work to do. In a lake, you can ingest whatever you want very quickly because you don't have to structure it. Of course, if you want to do something useful with it, you probably do have to structure it. But you're, in a sense, you get to delay that, and it can be a little bit quicker, and it makes it easier for data analysts and data scientists to get access to the data because they can typically do some of this more intense data processing. They don't need a structured area for them to work with necessarily. The other, I guess what I'd say, the other big difference is it's very easy to place unstructured data in a data lake, whereas you can store blobs, I guess, in your database. Within the HDFS file system, which most data lakes are based on, you can just drop whatever binary binary file you have into your lake, right? It can be video, it can be audio, it can be text, XML, JSON, whatever. So I'll talk about that. The storage is cheaper than with a traditional warehouse. You can use more commodity hardware. Everything is based on multiple nodes with parallel processing. So to add more processing power and more storage to your lake, you just add more nodes. And typically it's a lot cheaper than setting up an entire data warehouse with the intense hardware or the costly hardware that comes with. And then as we go through, I'll explain how this zoning gives you the benefits of a bimodal architecture. So a bimodal architecture or a two-speed architecture is an architecture that allows you in general to do the slow and steady processes while also being quick in other areas, right? So if you think about a data lake then you have a lot of our clients use their data lake in two different ways. They want to use it as either a hub or the basis of a reporting platform. And for their reports and their hub, they need very robust data. For a report, you need 100% of the data to be there, right? You can't produce a report and have only 4 of the fields populated. You need them all to be populated. You have to make sure that it's supported. So all aspects of, if the report doesn't get generated, somebody has to be responsible for making sure that it does get generated or fixing what the problem is. But it's also slow to change because there's lots of requirements. There's lots of design that goes into it. So when I talk about the 2 speeds, I don't necessarily mean how quick it is for the data to move through the platform. It's about how quick it is to develop the processes inside the platform to do what you need to do with the data. Nimble and quick comes because you don't need, for a data scientist to access that data, they don't necessarily need anything structured. They don't need all the data to necessarily be there. They need enough to be able to do the analysis that they want to do. And they're typically more advanced, they typically have programming skills and they can access this data no matter what format it's in.
Where do you handle data quality? In both environments or just a slow and steady?
So we handle the data quality in the slow and steady environment, right? And you'll see some of the functionality inside a data lake is a little bit less than maybe what you're looking for inside a data warehouse. I talked to a couple of people about referential integrity, and you're not necessarily going to have that in the lake. So you have to find ways to deal with that.
So where do you see most of the data lakes built? Is it on Hadoop platform, or there are some related data lakes too?
No, it's all, typically if you're talking about a data lake, you're normally talking about something like, I think you're almost always talking about Hadoop. I can't think of a different, well, you could be dealing with Cassandra, I guess, but go ahead.
Hadoop is great, but the cost is ginormous. Why can't we use S3?
You can, yes, all right. So there is an example, because you could build a data lake in Amazon's world using their tools, using S3. You can use S3 for storage, certainly, in the data lake, you're right.
When you were talking of bimodal architecture, you talked of enterprise architecture, right? Bimodal is great, but a company is as good as, it's as strong and as weak as its weakest link. The problem with bimodal architecture is you were sprinting, but at the same time you're limping.
Yeah, I guess, but I guess the benefit that I see is that you can use the analytics portion, right? Even if it's not necessarily complete. So maybe you're limping there, as you would call it, but you use that to prove out kind of your POCs or the metrics that you're looking for. And if you prove that out and you find something that's useful, then you can operationalize that and incorporate it into kind of the slow and steady back-end systems, right? Doesn't necessarily have to stay that way, but it allows you to start on some of the stuff and do some of the stuff before you have that entire process built, right? So again, The two-speed data lake would allow you to feed analytics quickly, somewhat painlessly. The pain really comes, it's really the data scientist's pain when they have to access that data. I'll show you what we do to kind of ease some of that and what I think helps in our design to ease some of that pain. But again, this speed is not as important to the back-end systems as it is to kind of those data scientists when they're looking for those new metrics or that new analysis. Whereas the back-end systems, they need the data to be complete and they need it to be quality. So an overview of the design that I'll be talking about, right? We have 5 zones in our lake. We have a raw zone where all the data gets ingested into. We have this structured zone that is approximately a mirror of the raw zone, but it's structured. There's a curated zone where your refined data goes into. There's a consumer zone that puts data into, could be cubes, it could be tables that are ideal for the users that are accessing that data. So if it's a report, maybe there's a table that supports that report. Maybe there's a cube that supports multiple reports. I'll talk about that a little bit more. And then we have this analytics zone, which is pictured there kind of across everything, because in the analytics zone, they're allowed access to each different data in each different zone, right? If they want it raw, they can go back and get the raw data. If they want it the curated data, they can access the curated data. Yep.
So are you storing the data again for every page in there?
Yep. So we do have redundant copies in a way, especially in the raw and structured zone. So in the raw zone, we're taking that raw data in and storing it. Well, I'll talk about each one and you'll see. But basically, yes, there is duplication of data in these zones. Is there another question?
Yes. With the structure that you talk about, it means that the raw data is structured, right? You structure the data in a format that
Yes.
the business of the guy can use it, or the CEO guy.
Yes, they probably could. Yep. Mm-hmm. It's just, yeah. I'll talk about the structured zone in more detail, but yes, it is typed, structured data, right? And not just, whereas the raw zone is just whatever file you received, it's stored in a file system. So that's exactly what I said. The raw data is stored in that format which it's received, right? So we just keep a copy of whatever we get. It could be flat files. It could be data from a relational database. It could be streaming data. And why do we do that? We do that because it allows us to validate data with the original source. If there's a problem somewhere down the line and we want to see where that problem originated, we have a copy of what the lake actually received. And so we know if the lake received the correct data or not. More importantly, maybe we can rerun historical data with new processes. So if we want to add a process, or if you want to even add data, refine more, you want to refine more data in a process, you have that historical data to go back and process with those improvements. And again, it allows you to ingest quickly new sources.
So this ingestion can be incremental and it can be full, whatever way we want, we can design that.
Yes, you can. Yep, we do. Well, we do both. Yep, we do full and we do incremental for the same client. So this talk is mostly centered around one particular client and the way we set up their lake. And for that client, yes, there was incremental data and there were full refreshes for some data. All right, so data coming in was coming in through RDMSs. We use Scoop, and I have one slide each maybe on each of the different technologies that we used, so we'll go over that. Again, we're ingesting XML, various flat files like CSV, JSON data. This particular instance, we're not ingesting any video or audio files, though for another client, we will be ingesting call center call data, which is audio files. There is some governance inside the lake, so this is based on the Hadoop platform. They're actually running Hadoop on top of Azure, though not HD Insight, which is Microsoft's version of Hadoop on top of Azure. I think it's Microsoft's version of HDP, pretty much, but this is just HDP, Horton DataWorks platform on top of Azure. There's some security, so Knox and Ranger lets you define security policies on files and columns and tables inside of Hadoop, and Knox lets you interface with your LDAP for security. And there's a note there that, so I don't forget to say it, but sources should not be loaded into the lake without proper documentation in some type of source registry, right? So especially when we talk about our raw through consumer zones and not necessarily the analytics zone. But for the raw zone, any data that comes in, we want to make sure that it's documented. We want to make sure we have a data dictionary defined for it. We want to know what fields are in there, what they mean, how they might relate to other things, and how that data can be used. And so we don't let anything into the lake without that. And in our case, it's really just documentation. Currently, they don't have a data governance, they don't have software to help them support some of that. Another client of ours is using some software that helps them. They define their data dictionary inside software. They define what all the different terms are. Kevin, I know, is very familiar with that, more so than me even.
So is Atlas serving as that registry?
It is, but it lacks a lot of functionality right now. They are working on improving that functionality.
So it's on-premise database and the lake is in cloud.
For this client, that is correct. Actually, a lot of the flat files are coming in from an on-prem source. They're interfacing with a database that is actually another third party, so that's not on-prem. It's hosted by them. And this is hosted in the cloud, right?
So in your case, you have to manually kind of document it. Is that what you're saying?
Yeah, we make sure that anybody who's bringing data into the lake, make sure that those files are documented.
What is document right now? Is there a best practice when you create like a small database where you document?
They use SharePoint. It's basically a SharePoint with Word document. There's a template that they need to fill out. There's a specific data dictionary template that they also use that the document links to. There are some required fields in that template. There's a lot of required fields in that template. Some of them is for risk assessment. They want to make sure that the data that they put up there is allowed to be up there without any special security. So now, at this point in time, all of this is encrypted, except for, I believe, the edge node itself, which is just a server where we FTP or SFTP the various input files from. But all the HDFS is encrypted, actually, and the scoop transfer and the SFTP, it's all encrypted. So I'll talk a little bit about some of the tools that we use before I go on. So in the ingestion and portion, we use a tool called Apache NiFi, created by the NFS, built to transfer large amounts of data quickly. It's very easy to design flows within NiFi. It provides its own repository, so it's a web application. As it processes files, if for some reason it goes down, everything is stored, so when you restart it, it comes back up to where it was and can continue processing whatever file it was processing when it got interrupted. It does have a provenance repository, so you can see how the file moved from one process to another. This is something that's very hard to see, but it's really just an example of some of the process groups that can be created in NiFi. Each one of those boxes is a separate process. It might be something as simple as setting up a variable name, or it could be they have processes that allow you to do that SFTP. You can run a shell script. You can insert into Hive. You can create schemas in Hive. So we use it to ingest the data. We check the numbers. In some cases, we're doing some validation checks. We're checking the number of rows, making sure that if we receive metadata with that file, and it told us how many rows we were expected to receive, we received that amount of rows. If there are some fields we don't want to be null and the file contains them, the process here will reject it and send an email to somebody to let them know that it was rejected. Go ahead.
So is that like an ETL?
Yeah, it doesn't do a lot of transform, really. So the transform that we do, we had to write SQL for, or HiveQL for, inside of the tool itself. So it lets you run some of that stuff, but it's all, right. It does do some transfer. It can split a file into rows and let you individually process in each row. It can do merges. It can uncompress zips and stuff, but it's not a real ETL.
Analogous to the relational world, when you're dealing with files and data, you use an ETL tool.
Right.
Informatica.
Yeah, I don't know if I would say it's analogous. I think it does part of what those tools can do, but not all of it.
More like a job control system.
It almost is.
Right.
Yeah,
Or
I guess
it's-
you could say it's more like a.
Where you're
job
stringing
control
together
system,
steps to do certain things, and it's not an ETL heavy tool.
but right, and it's geared really towards the ingestion, right? So the main processes there allow you to bring in data from lots of different sources. So various messaging services. You can ingest data from a database, though we use Scoop for that and not NiFi because NiFi is slower in that area. What we do in our raw zone and our structured zone is we do use NiFi to help us create the structures that eventually store that data in the structured zone. And we have NiFi processes that do all that automatically. So, but you do end up with something that looks very long and complex because it's not, I guess it's not necessarily what NiFi was originally built for. I think it's better at doing the first part of that ingestion. It's really good at quickly ingesting. It can, pull an SFTP server and bring in data. It can make sure it doesn't take the same file twice, or if it doesn't delete it from the source. Did you have a question?
Yeah, just a quick question. I know you mentioned something about a require, kind of like a constraint. You can put on like a require or mandatory field. What other constraints can you put on? Like, I'm coming from a typical RDBMS world. Is there anything like a primary key kind of thing, or no, just?
So when I say we put on that constraint, it's more of a programming constraint, right? We have to go in and check for that. It's more like, think of your data lake, any of the constraints that are in there are all kind of in the application and not enforced at the platform level, really. But yes, so you can program almost any constraint that you want, but you do have to program it yourself. All right, so here we would be looking through a file, and if there's a column that can't be null or it doesn't match, say that, I guess a more typical example is it doesn't match the metadata that we receive. So we're expecting a certain structure for a file, and the file comes and it's not that structure. We do that comparison programmatically, right? And we just call that from a processor in NiFi. Scoop is another tool that we use, and we use this to import data from an RDBMS because it's a lot quicker than doing it in NiFi. I've heard that NiFi is going to make their SQL ingestion or their RDBMS ingestion quicker, but for now, Scoop is the preferred tool. And even for another client who's using a more advanced tool, they also use Scoop for the RDBMS import right now. It's pretty simple to use. You just provide a connection string, your username and password, or you can more normally, I guess you'd have it stored somewhere, and it wouldn't be visible in the command string here. But you don't. This almost is a more advanced version of Scoop because we have an actual query in here. You can actually just specify a schema and table and tell it which field. So if we were just doing this probably exactly like that query says, then we would just, you could just tell it that you wanted to get data from this positions table, and you want to use the last change timestamp as kind of the indicator of change. And so it will automatically keep track of the last time it did this and what it used for that input. And so next time it runs, it could just get all the data that was added after that time. In our case, it's not typically as easy as that. There's a few fields we have to check, and so we had to provide a query to it. There's you see that M6 tells it that you want to use 6 mappers, so it runs 6 simultaneous processes to get this data. And the target directory tells it where it's going to go, how you split that data when it gets it. And all the data comes into a temporary source area. When it's complete, when it has all the data, then it transfers it into kind of our raw zone. And that's just a function of scoop. If it fails, none of that data gets into the raw zone and none of the timestamps are updated. So you can just rerun it. And that little picture there, just shows that source data going into, just goes into HDFS. What our process basically does is takes the data and goes into a CSV file in HDFS. You can also use Scoop to go directly into a managed Hive table. We don't do that because we want a raw sample of exactly what we got and what the changes were. If we put it right into a managed table, it'd be a little harder to see what the real raw data was as it came in. And that brings me to Hive. So Hive is a SQL-like interface that lets you access not only databases in HDFS, but files in HDFS using SQL, right? With some slight changes to the syntax, but it's mostly ANSI SQL. I think it supports most of that. A managed Hive table is very similar to a table you'd be used to in an AR DBMS, except that it doesn't support primary keys or foreign keys, but it does let you put in, you have typed columns, you have rows, and you access it using SQL. An external Hive table is pretty cool because it allows you to create a structure on top of files that you stored in HDFS. So if you have a bunch of CSV files and you know what those columns are in that CSV file, you can just define the structure in Hive, create this external table, and you get a non-updatable, readable table structure. So you can use SQL to access that data. You don't have to use any kind of Java or Python to access the data inside of HDFS using this. The only real downside is if you use an external Hive table, you don't get to type it, really. It's not very good at typing the data in those files. Everything pretty much comes up as a string, which isn't always useful. So the last one, Uzi, is a workflow manager inside of Hadoop itself. So it doesn't really do anything external to Hadoop, but inside of Hadoop, if you want to run, for example, I have an XML file there that shows how you can run a fork and join running a bunch of different Hive QL queries. So we have what we call waves. Each wave contains a number of jobs. Typically, they're more than 2, but it's a simple diagram, so I put 2 up there. So you run 2 at a time and go through. Question?
For the 5 zone that you talked about, is this the logical or is it like a physical level?
No, these are actually physical. Yep. So they're all within HDFS, but they're in different directories, inside of HDFS, actually. And the databases themselves are in different database files. So when you create a database in Hive, it creates a DB file in its Hive directory, and all the data that you put into your tables in there will be in that DB file. So this lets you run jobs in parallel, right? So you can run as many as is feasible with your cluster, basically. All right, so now we've talked about the tools. I can talk a little bit about our structured zone. So our structured zone, I think, is what makes this architecture a little bit different than other data lake architectures. In other data lake architectures I've heard about, the structured zone is typically optional and not always complete. What we do is any data that comes into that raw certified zone, we make sure it has accompanying metadata so that we can create a structured area for that data. Right, so if we're getting in a CSV, we have a metadata file that describes what's in that CSV, we can create a structure to store that data. What it does is it allows others, not only data scientists, but say business analysts who know some SQL can access that data and validate that data without having to do any real programming. As long as they have, say, SQL developer and they know some SQL, they can access that data. So I have some other pictures here. So the structured zone, any data, again, any data we take in using scoop or file transfer, whether it's XML or JSON or a CSV, comes in, gets stored in that HDFS. We put an external Hive table on top of most of it. If it's, I guess on top of all of it. Some of them are temporary because really what we want to do is use that to get the data into the structured zone. So again, that structured zone, since it's in a structured database, it's in a database, it's in its own DB file in Hive. In some cases, we use Uzi to manage some of those jobs. Mostly that's just to call scoop and manage the scoop job, or the scoop raw to structured transfer, but really, I don't have it on the diagram, but NiFi kind of controls this whole process for us. So going from the external source to the raw zone to the structured zone is what all our NiFi jobs are built to do. And so any data that they add, as long as they add a metadata file with it, it goes into the structured zone. And if the metadata changes, the processes are built so that they can detect the change. Mostly if they receive a new metadata file, it means that the structure has changed. They take that metadata file, they rebuild those structured tables, and they reinsert all the data into those structured tables.
So the raw to structure, it's mostly Hive queries and Hive scripts.
It is, because we're using that external table, we can do it using Hive. Right, so a really simple one is just drop in a CSV file with a properly defined external Hive table structure on it, and you can do a select star into your managed Hive table, and then you have it. It's not usually as simple as that because, like I said, there's typed data. You want it to be typed in your managed table, so there might be some slight transforms that go on in there, but it's still fairly simple. Harder ones are when we deal with XML files. So in this picture here, the bottom one, we have flat files in XML and JSON. So for XML, we use the XSD as the structure. So that's nice because it already has a metadata file associated with it. So we validate it. We create tables. So with XML data, whereas a CSV file, you're going to end up with one CSV file or a set of CSV files, one structure, one table basically in your structure. XML, you can have lots of sequences, you can have different, you can have repeating elements, and so we end up with multiple tables in our structure. So we might have one example, one of the more complicated ones. I think we have one XML file or one XSD is used to create 20 tables in our structured zone, and is populated depending on what's in the actual XML that we receive for that data. And at the top for the RDBMS, we actually use NiFi to get the DDL, so we get the structure of the database in Oracle, transfer it, and pretty much recreate it in Hive, and then we use Scoop to do to get the actual data, create the CSV, and then do the transfer from the CSV into the managed Hive table. Right, so just to be clear, a raw zone, file-based, all files, CSVs, XMLs, JSON, structured zone, actual database table that you're probably all familiar with, right?
You're not doing any sort of aggregation or anything?
Not yet, no, not at this point. So that structured is really like, it's just a one-to-one mapping of what came in. So we don't do this for this client, but you can take, example of taking some audio or video file. Maybe you bring in that file, you store it as it is in HDFS, and then maybe you do some transcription to get the text of whatever is being said in the audio file into a structured table that you can then query, right? Or you can, there are tools from Amazon that let you go through, or Google will let you go through video files and describe what's in each scene, or pictures and describe what's in each scene. You could do that also in here. So the curated zone is when we start doing actual data transforms. Right, so this data is heavily transformed, it's refined, it contains a lot less data than we have in our structured tables, because another philosophy that we have, and that I think if your intention is to build a data lake, you should really consider anytime you touch a source, take all of it. So if there's a source file that's coming in and they only need 4 fields from it, just take the whole thing. If there's a source database that's coming in, take it all, right? Storage is cheap these days, should be cheap for you. And what happens is requirements change. The field that they didn't want 3 days ago, they suddenly want, and instead of having to go all the way back to your source and finding out how you're going to now change your process that creates your extract to get that, you already have it in your raw zone. It's much easier to just change the transform inside the lake to include it. That actually happened to us in this particular project. I think we were like 2 weeks away from going into production, and somebody on the client report side said, "Oh yeah, we forgot we need these 5 fields." Normally that might take a while, but we already had those 5 fields ingested. They were sitting in the raw zone. Nobody was actually transforming them. So we modified the structure in our curated zone to hold them, and then changed the HQL queries, or the queries that populated that curated zone, to populate those fields. And it only took a couple days as opposed to weeks, possibly. Right, and in this curated zone, the data is going to be validated. So if you have processes, so again, you have to create your own processes. So we have, I think I might have it in a picture. Yeah, I talked about it here. But we have processes that do this kind of referential integrity check on the fields that are very important in the curated zone. But it basically happens after the fact. After these tables are created, we output a report that says, if there are any, these are the fields, these are the rows that don't conform, that are missing either foreign keys, or the foreign keys don't actually match anything that's existing. So we use Uzi to control that structured to curated zone process, because in that zone we have a bunch of HiveQL queries that are being executed. In this particular project, their curated zone is not just refined and aggregated data, but it's really a data warehouse. They actually take transactions in the raw zone and the structured zone, and we do our CDC logic in the transform from structured to curated. In one case, in the Scoop database case, we're actually pulling from an existing data warehouse. It's a third-party tool. They have a data warehouse we can extract from. They do CDC, so we don't have to do as much logic there. But really, since we are combining it with other sources, we end up having to do a lot of logic there anyway. So I guess it doesn't really save us much. So the important thing about the curated zone, this is where our modeling occurs, right? If you're going to model the structure, and that's because this zone is used for populating the curated zone and using tools like I don't know, any kind of reporting tool like Tableau or Click or Power BI. You're going to access your data you can access your data in your curated zone here, right? One more. So we have a total of about 30 Hive QL scripts. Some of them are pretty complex. Some of them are really simple, but most of them are at least somewhat complex. 3 main sets of jobs. It takes about, so these 30 Hive QL scripts populate about 30 dim and fact tables that exist in their, they call their data warehouse in that curated zone. In the end, it takes about 45 minutes to run the process to populate those and to populate the consumer zone, which I'll talk about in a second. Again, each wave runs as much in parallel as is feasible. If we had a larger cluster, we could run more in parallel. Right now, we do not. And just I guess what I would consider kind of a funny anecdote, they have it runs in the Azure, right? One of the aspects of Azure that's supposed to make it so easy, so good for this kind of process is that you can easily add new nodes, right? Because they don't have to purchase new hardware. They just have to spin up a new virtual machine or whatever and plug it in. Well, it takes about 3 weeks to process the paperwork to actually do that. So whereas it might take I don't know, it might take the technician about a day to spin up, in the end, to spin up that virtual machine, it takes 3 weeks of paperwork to go through before we get it, which is, I thought, kind of amusing because it kind of defeats the purpose, but oh well. And again, RI checks here are done after the curation runs, so where we have some checks that are done on ingestion, we have others, obviously, that can't be done until after curation, and that's basically checking to make sure that the foreign keys exist, that kind of thing. That all happens here after the data has been populated. So the consumer zone, again, data is provided in structured tables. These structures are more flattened. So in this particular example, they use their consumer zone is a set of 7 cubes that they create here in the lake. And then they have a small set of flattened files that are used to go to other applications down the line. But since this is used for client reporting, those cubes are used to generate, I think they're used to generate all of the client reports, actually. And the flattened files are just used for other applications that might need access to this data. So we create this consumer zone because it's easier for the consumers to go in and access a flattened structure than it is for them to figure out how to do all the joins and access curated structure themselves. Picture. So in the end, we have our raw zone structures on curated zone going into our consumer where our cubes are, outputs to either a reporting server or external apps. Again, all managed by Uzi. So once the curation is done, there's an Uzi coordinator job that is set up to look for the completion of those jobs, those curation jobs. Once they're done, the cube jobs are kicked off and those run. That's what I just said. So again, those cube jobs are more Hive QL scripts. Really, they're not that complex because in our curated zone, every row has a UUID. So every row is unique, and so the keys relate to a specific instance of a row. So if a dimension changes over time in our fact table, we just have a UUID for a dimension that relates back to that dimension. Makes the generation of the cubes a little bit easier because they can just join everything using those UUIDs. And again, they have scripts here. We have in this area to actually validate the data and alert support if there's problems in this generation as well. So I do have a note there that says all alternative consumer marks technology might be Oracle databases or NoSQL. You know, we heard that they wanted to create these marts or this kind of a true warehouse. We suggested that maybe they don't want to create that warehouse itself inside the lake. But it is, the hardware is cheaper, the storage is cheaper, and it was cheaper for them to do this. They had to get around, we had to prove out that we can enforce that referential integrity through programmatic scripts because they're an investment company. They really need that data to be correct. They can't send out reports with incorrect data in them. So we did do that. So those scripts are pretty robust that run at the end and make sure that everything is okay.
How's performance?
Yeah, like I said, so it takes about 45 minutes to generate those each night. To do the curation, it takes about, I think that includes actually creating those cubes. So the ingestion takes, you know, if you add on ingestion time, but so I didn't really talk too much about when the ingestion happens, but for different sources, it happens at different times. Some of them, it happens throughout the day. So some of those XML files, they come in at a few times, they come in throughout the day, right? It's some of their master data that they're managing, and changes is made to that data, then the change gets propagated down and it comes to us or to the lake, and the lake processes it as it receives it. Some of the other files they process as they receive, so there are some third-party CSV files that they receive. As soon as they get it, it gets processed. It's really the main driver there is they had RDBMS, which is really their accounting system. Once all that data for the day is processed and put into their lake that we get the data from, then we can process that data. And that happens currently, that happens once a day. Right now, by the end of next month, it'll be happening a few times a day. But that's it. Yeah. So it does take it takes some time.
I guess I was focusing more on the performance of the queries to the, you know,
The sources?
dimensional tables, your cubes.
Oh, those cubes. Yeah, so honestly, I can't speak to how long it takes to do those queries because I'm not a consumer, but I haven't had any complaints. We haven't heard any complaints about the way those are set up. And like, again, everything is flat in there, so there's no joint. Like, what takes the most time in this transform here is doing some of those joins and that process. It takes a lot, it does take Hive effort to process those joins. It can split up some of the process. Some of the transforms can be split up to a bunch of different nodes. But then you get to these reducers, so it's all split up in the map reduce job. You end up with one reducer at the end that's doing the last join, and that can take a while. And that's really where a lot of the time gets sucked into, especially if you're not careful about how you structure your queries.
So we have to use the map that like in this framework.
Well, so when you write a HiveQL query, so you can write a HiveQL query, it gets converted into a MapReduce job.
But you don't have to
MapReduce
do
job.
it.
You don't have to
But
program the job itself. No. Go ahead.
You mentioned for the curated zone, you said RI is checked after the curation one.
Mhm.
I just wanted to understand, I was thinking RI would be checked beforehand.
Yeah. Well, we can't check it beforehand because the data hasn't really been created yet there, so we check it after it's been created. Well, we do create a set of tables. We preserve, yesterday's tables, create a new set of tables, do the RI checks on them, make sure they look okay. And when they look okay, we transfer them, we swap them, basically. But yeah, we do do it pretty much after that data has been created and is in those tables.
So what happens after you have your curated one, there's issue with the RI?
So if there's an issue, that means that they can't generate the reports that they need, then it has to be corrected before access to the cubes is granted before the cubes are switched out. Or before maybe even before the curated tables are switched out. But it's really, nobody accesses, except for, say, which I haven't gotten to, the analytics side, but those consumers don't access any of that curated zone directly. They access the cube. So really, we don't generate new cubes until the data looks good. So if there's a problem, a lot of times, so in the beginning, when we first rolled this out, there might be some issues because a different type of data came in that hadn't been seen from the source before, or they misunderstood we had issues where they misunderstood some of the requirements. And so the curated tables weren't being created correctly. But once we work through all of that, most of the problems that you have in the curated zone is because the source didn't provide you a proper file, right? Or in the case of the RDBMS, when they loaded that data warehouse, either it wasn't loaded at the time or it was partially loaded for some reason. They're only supposed to tell us that it's okay. They're only supposed to send a trigger file that kicks off the whole process when it's complete. But sometimes that doesn't happen. And if it processes it in the middle, we might end up with some fact rows that don't have dimensions associated with them in the end, and so they have to rerun it. But then we go back to the source and recreate that data and rerun it. And the type tables or those structured tables are set up. Basically, data just gets added to those at all times. And so when we do our processing from the structured zone to the curated zone, we're filtering out any duplication of data, especially when we do that CDC logic. So if we need to rerun one of those sources, or if they need to send a corrected CSV file with updated data, then they just send a new file that has updated data and we run the process again. So I've talked a lot about the analytics zone, but it's basically set up for data analysts and data scientists. It's a separate zone, so it's a separate area where those users can actually add their own data sets. So they can access data from any of the existing zones. They're usually not too concerned with the consumer zone, and they're usually more concerned with the structured zone or even the raw zone. But they can add to that by importing a CSV that they have. Maybe they have a third-party data source that they want to integrate with existing data and see if it integrates well or how they can integrate it, so they can use this area to do that. They don't have to register that source when it comes in because none of this is being used by consumers or being used by our curation process. They do have to be a little bit more technology savvy. So since we have this structured zone, they at least need to use SQL to be able to access that data. But a lot of times your data scientists or your more advanced data analytics people are going to be more, they're going to be running Python jobs or their own Spark jobs to do analytics here on the database. In our particular use case here, or our project here, our analytics sandbox sit on top. It's currently mostly a manual process to populate those sandboxes, as we call them, right? So every user has their own sandbox. They can request data be added to or access to. They can add whatever sources they want to this. I think they can access anything in the structured zone. Again, it's controlled by rangers, so I think it depends on their role. But typically, they have access to everything in there.
They just move the files.
Yeah, or subsets of the files or the entire thing. They can copy that into their area and then they can add whatever they want to it and process it however they want without affecting what's actually happening in that bottom horizontal there.
Well, I don't, in your early comments, the concept of the data sources, I do see you use Smooth and you use other technologies. You don't use Spark?
Not for this. So for the data analytics, the data analytics group does use Spark when they're processing a lot of times, and they're doing
So, I mean,
their analytics, but not to, we're not using Spark, no. No, we investigated running some of those Hive jobs in Spark. Right, you can do
My
that?
understanding is Spark, you can do away with Hive, do away with, Squid, because you don't really have to worry, because you don't have to worry about it translating to method use. It's doing everything.
Yes, it's true, and it's fast, it can be faster, right? It's a whole different skill set as well, and so, for this, right now, we're getting the performance that we need out of Hive, and since we haven't moved to doing any of that in Spark. But Spark, yes, is an option for that. Yep, go ahead.
So, I'm wondering, if the data scientists also have the ability to inject data into the system, do they have the same roles as the DE guy who is in charge? For example, I inject the data into the system and I want to extract it somewhere. Would I have the same, like, role and be able to manage it into my own way?
Yeah, so inside that's why they have their sandbox, because inside their sandbox, they can create whatever structures they want. So they can pull data from, say, that raw zone, if they wanted a completely different structure than what's in our structured zone, or if they wanted something completely different than what's in curated, they can pull that data from structured and create whatever structure they want inside their sandbox, right? And if they come up with, if they determine that, I don't know, this new data source that they found they can integrate it with what they have and they want to add it to these reports, or they want to add that input to some other system down the line, then we can operationalize that process. And then we go through the whole thing of making sure that we have the documentation needed for the source, that we understand when it comes in, how it comes in, the format, and we create the whole process. But again, that's a slower process than for that analytics user. Right, and so we want to move this to self-service. There are some tools to help. So I think there are some tools. If you buy, I think Informatica has something that lets you do this entire. If you do everything in Informatica, you might be able to do some of this more self-service easier. You can integrate with some third-party tools like Calibra, which has some triggers where you have to write some code, but it does allow you to, since it's a data governance tool, it has the entire data dictionary in there. It allows people to go in and browse that data, select from the different sources. They actually have a functionality in the, I believe the newer version that lets you kind of add it to a shopping cart and say, these are the sources I'm interested in. It can get approved, set the workflow where it can get approved by different managers. And if it is approved, then it gets loaded into their sandbox or into wherever. In our case, it would be into their sandbox. Any other questions here? I think basically this kind of wraps it up. So our two-speed data lake, as you've seen, the green area really happens quickly. So the ingestion processes are built quickly. Everything it's mostly template-based now. So if we get a new CSV file, we get a new XML file, we get a new database, we just use the NiFi template that we have to ingest that data, which allows us to quickly set up a process to get that source from the raw zone into the structured zone. The hard part is making sure that the curation happens properly, right? Because that has to be done right. And those curated tables have to be correct so that when we run our RI checks, they do not report errors. And that's where more of the programming work more of the effort actually goes into. Go ahead.
So how much effort was put in the architecture, like which curated zone, which Hadoop zones to use and compared to consumer zone, because you want to use multitasking, distributed processing and all. So all these zones, so how do we architecting these, putting in the entire Hadoop file system so that you can parallelly perform it all?
Mhm.
managing the workflows and all those stuff. Is it a lot of architecture in that part, or is it
No, I mean, you can run, so you can get parallelization, especially in any of these processes by using Uzi and defining your jobs within an Uzi workflow, which allows you to, so let's say we have those 30 HQL files, right? So each file is not, some of them are very long, complex sets of queries, right, that create those dimensions and facts. So inside of Uzi, we have these different jobs that are set up to run, say 6 of them in parallel. You know, we might have started off running 3 of them in parallel, and I think now we're up to, for some of them, we run 7 in parallel. We found out for some of the fact jobs, we don't have enough nodes in our cluster. I don't know why their cluster is so small. It's a little small. So we had to split some of the fact table generation because those jobs take a long time, or they're really intense. And one of them could hog the entire cluster, basically, for 5 minutes, say, while it's running. And then the other ones are just stalled. And it's much easier to create, we change our XML around, and now we have like three of the smaller jobs run, and then one, or something like that. It's a lot quicker that way, but it's easy to achieve that parallelization just by doing that, right?
Anything about security?
Yeah, so security, like I said, it's controlled mostly by Ranger. So within Ranger, you can define, you have different, essentially you have roles that can be, and you can say that a role cannot access a certain file, a certain column, a certain table. We don't allow any consumers, for instance, to access anything except for the consumer zone itself. They don't have direct access to that curated zone. Some users the entire lake is actually segmented. So this solution was set up for one division of this company. The lake itself is this platform, and the lake itself is shared by different divisions, and it's actually completely separate so that none of my development team or none of my team can see anything in those other segments of the lake, those other areas of the lake. And again, it's integrated with LDAP. So to sign into this, well, it uses Kerberos, which is kind of a pain to set up sometimes, but once it's set up, then you can run, say, SQL Developer and access any of the databases that you're allowed to have access to. And it's all controlled through Ranger. And which is a set of XML files. There are UIs for all these things. So for Uzi, there is a UI that I think you do have to set up your job in XML, which isn't as much fun as dragging and dropping, but to control the jobs, there is an UI web interface that lets you see what jobs are running, how well, like you can see within one particular Uzi coordinator or Uzi workflow, you might have 17 jobs. You can see which ones are running at that time. You can see if any of them failed. If any of them failed, you can see why. And you can do that within the Uzi console. There's a Hue console that allows you to run SQL. If you don't want to use something like SQL Developer, which can be a little time consuming to set up when Ranger is involved. But I guess that's it. Yeah. Anything else? Go ahead.
Yeah. So I see a lot of the advantages of this, and I understand the two-speed advantage. What scares me is when you say data scientists have access to data in all the zones.
Mm-hmm.
Who's governing that? Like, who decides who's a data scientist and can take raw data and say something to senior management?
Right.
It's very dangerous. I guess I'm skeptical because I spent years.
Yeah, well, I agree.
Trying to defend all of this and try to keep people from taking raw data and making a silo and calling it gospel. Where's the
Well, that's the
government
thing,
for
so-
one version of the truth?
Yeah. So anything inside those 4 zones is considered the truth. Anything outside of those 4 zones is not considered the truth. So
But the raw
But we
zone
allow-
is totally uncurated. How could that be one version of the truth? I
it
understand.
is the truth because it's coming from the source of truth. Like
You
when
don't
when we source that raw zone, we're not going to, I don't know, an access database that got its data from a different system that, right? We're going to that
Right.
source system and
I get
getting
that,
that data.
But
But I agree that yes, you do have to be careful with who you define as a data scientist and what you allow them to do, right? You don't have to let them see all the data in there. I guess my point is that you could let them see whatever data they would want to see in there.
I think it's
Especially
important.
in the case where you can bring in external data in
Mhm.
addition to what's there
Yeah.
to begin with. Now you're bringing in another element.
You are. And that's why it's sandbox, right? And that's why you want to allow these people to do their job, I think, at least I think. You want to allow them to do what they were assigned to do. And so this allows them to do that without messing up anything else that you've created and without destroying any of that truth that you've
For
said.
the data scientists, I don't know whether they care about the truth, because our data scientists want all the data, so that they can find everything. in it.
Totally, I
But
totally,
if the executive dashboards and all, that's a curated zone, a consumer zone.
But then you have surveys also that have to conform.
right.
Yes, you
There's
do.
there's a lot going on. So
Mhm.
everything, and I get it, the analytics zone, you hit it the nail on the head. It's very important to let people play. And that's why it's called a sandbox. I think, you know, that's the important part of an analyst's job is to, you know, I hate to use a cliche, but think outside of that sandbox and bring other toys in. But
Right.
you
So,
have to have
so
governance of who
they're
speaks.
probably not going to be
decisions.
pulling in social security
Business.
numbers or something, and if they are, they're going to be masked, right? There's going to be a process that masks those. So right now, like I said, all this is manual, so that happens manually. Ideally, it would happen automatically, but
Yeah, that's
yeah,
why they
you're not going to,
lake without down to the sun.
Yeah,
And they-
yeah, it's one, yeah, absolutely.
I even have a customer that, takes that sandbox and they have sort of an internal and an external sandbox. And let their customers actually come in and play with data. But
really.
they don't expose everything.
Mm.
They have jobs set up that handpick and, you know, depersonalize the data, they sample the data, and then they create stuff that allows the customer to come in and join whatever data set they want with it. And see if they can find anything, but then they go back to the
Right.
customer. Hey, we'd like to see this in your data.
I wanted to tack on to the data science, checks and balances, right? With some of our data scientists, we do let them have a sandbox space where they can play and, they're presented with this business problem and they theorize and play around to try and solve that problem. But that doesn't become the solution.
Okay.
They still have to then figure out how they're gonna integrate and operationalize. They're gonna be talking to the data owners, they're gonna be talking to a lot of different people, business needs, they're pulling in all kinds of people to make sure that what they're proposing is actually something that can be used and maybe even operationalized.
I think that's an important point, that business needs and that those sorts of meetings have to happen. I think, everybody's run across this in their career, somebody who knows enough to be dangerous. I had my foot in both camps. I've been in technology, I've been on the business side. And you get this person who just comes up with a report and you're like, where did you get that? That's totally wrong. And they, got some, in this model, something from maybe the structured zone and curated themselves. And they're, it makes, you have to have those meetings where, you don't want to handcuff people, you want them to be productive, like you said, but there's a danger.
Our scientists don't like that.
And
Right.
if you want, sometimes you can go to the consumer zone and still write the wrong query and get back.
Yeah, yeah.
The
government-
It is a lot harder to mess up in the consumer zone,
Right.
at least in our design, right? Because everything's very flat, everything's already joined for you. There's not a lot of weird things you're gonna do in that zone. You're gonna get the data a lot of the way.
When data scientists, when they production line, they deploy their models and that goes through the whole different audit process.
Yeah, I think the audit and the peer review is very, very important.
Yeah, that's fine.
Okay. In the interest of time, we're gonna switch presenters. I'm gonna hook up a different machine. If you have to use the restroom, you got 5 minutes. And it's right outside this wall, right over here. Cool.